Hey everyone, welcome back to the channel. In today's video, I will be configuring OSPFv2 routing in a simple three-routed network. If you're new to networking or cybersecurity, don't worry, I will explain everything step by step so you can follow along easily. Routing is a key part of how the internet and private networks work. Instead of manually telling routers where to send data, we can use a dynamic routing protocol like OSPFv2, which means open shortest path first, to do this automatically. This makes network management faster, smarter, and more efficient. The IP addressing for routers and devices has already been set up in this exercise. So our focus will be configuring OSPFv2. This protocol allows routers to exchange information and automatically find the best path for data to travel across a network. We will be working with a three router topology, meaning there will be three routers in our network, all connected to each other. Our goal is to configure OSPF so they can share information and establish communication. After that, we will test and verify connectivity to make sure everything is working properly. And I bet you're asking yourself, why is this even important? In cybersecurity, understanding networks is key because attackers often exploit misconfigurations. If OSPF isn't set up properly, it can lead to downtime, slow traffic, or unauthorized access. A well-configured OSPF ensures data moves securely and efficiently, and this makes it harder for attackers to exploit any weaknesses. OSPF is also flexible. Unlike static routes, it adjusts automatically when changes happen, which is why it's used in large networks. Learning OSPF helps you build a secure and adaptable system. Now, let's take a closer look at the network we will be working on. This is a small setup with three routers. We have R1, R2, and R3. We also have three switches as well, S1, S2, and S3. And finally, we have three computers, PC1, PC2, and PC3. This setup shows how different parts of a network called subnetworks connect and communicate with each other. Each device has a unique IP address. For example, PC1 is in the 172.16.1.0/24 network, and PC3 is in the 192.68 I'm sorry, 168.1.0/24 network. So both of these computers are in different networks. And let me try to explain it a little better so you guys can understand. The PCs connect to the switches, which let devices in the same network talk to each other, right? The routers connect to different networks and figure out the best way for data to travel between them. For instance, if PC1 wants to send a message to PC3, the data will travel from router number 1 to router number 3 throughout throughout the switch number 3, and finally it will reach the computer number 3. Think of the routers like mail hubs. Each network is like a neighborhood, and the devices are like houses. If you want to send a letter or data from one house in a neighborhood to another one in a different neighborhood, the mail hub, which is the router in this case, will make sure it takes the right path and it gets delivered. So in this video, I will configure the routers using OSPF v2, which is a special protocol that helps routers automatically learn about the networks connected to them and find the best path for data to travel. After the setup, we will test everything to make sure all the devices can communicate. And this lab is a great way to understand OSPF and how it keeps networks running smoothly and securely. And also, if you want to try to do this lab at home, I will also show you the IP addresses and the way you need to configure your routers and switches and PCs so you guys can mimic from home. We can see that our network is made up of three computers, PC1, PC2, and PC3. We also have three switches, S1, S2, and S3. Additionally, we have three routers, R1, R2, and R3. We need to use the following requirements to configure OSPF routing on all three routers. For this, The first is using a process ID of 1, the second is using the network addresses of each interface, and the last requirement is that the LAN interface should be set to passive. Alright, so for this, let's open router number 1, go to the CLI tab, and enter the command en or enable to turn on the privilege mode. After that, to enter the terminal configuration, let's enter the command confd or configure terminal. Now let's enter the OSPF1 configuration by running the command router OSPF1. Let's define the network addresses for each interface by running network 192.168.10.4.0.0.0.3 area 1, network 172.16.1.0.0.0.255 area 1, and finally network 172.16.3.0.0.0.0.3 area 1. Now let's set the LAN interface to passive by entering passive interface gig 0/0. Let's leave the configuration by running the exit command and the exit command again. Now we're going to do the same thing for router number 2 and number 3. Now we're going to do router number 3. We're going to do the same thing. Which router should not have a route to every network in the topology by doing all this? We can see this in the routing table. Let's run the show IP route command and see if we can find the sign for the OSPF routing. We can see the codes here on top and what each letter represents. We can see that the OSPF represents by the letter O or 0. So let's also see if we can find in router number 1 the line that shows OSPF routing. So yeah, so we can see that the lines that show the OSPF routing on router number 3 private network is 0, 160 is this line right here. All the computers on the network should be able to ping each other at this point. Now let's ping PC2 and PC3 and PC1. Let's open PC1, go to the desktop tab and open the command prompt and run ping 172.16.2.2. So we can see that the ping was successful by doing this. Now let's ping PC3 now by running the command ping 192.168.1.2. We see that the ping was successful as well. So we completed the configuration OSPFv2 in a single area.